Hello, students. Next questions coming in. These ones are about uh, fraction form and how to know about repeating decimals. So repeating and terminating decimals, they all tie back into the 2s and 5s. So for example, if I had the number 1/6, I could factor it. Prime factorization is big. Separate all the 2s and 5s into one area. That's the portion that will either be terminating or be the thing that does not terminate. So from here, I can tell you right away that it repeats because in simplest form, it has a 3 in the denominator, and 3 is not a 2 or a 5. Okay, repeats, and I can't tell directly just from the number how long until it repeats, but I could say no more than 2 digits are in the rep of 10 because it's a 3. But also this 2 down here, because it's a power, because it's part of powers of 10, I could say 1 digit not repeating. Okay. And you could actually check this 1/6. If you do the division, turns out to be 0.166666666. So one digit repeating, which matches the no more than 2, and there is 1 digit that is not repeating. That's where that one comes in. Okay. If you want to see how do I know that, you can do either the long division, which I recommend in this case, probably it's quicker. So you could just do 6 divided into 1, and 6 goes into 0, 1, 0 time. That leaves me 1 behind, gives me 10. 1 times 6 minus equals a 4, 0. 4 goes in here 6 times. That's a 36. When I subtract, I get 4 again, and you could say, boom, I know only 1 digit's repeating. It's the one that just started right there, so it's just the 6. If you kept going, you get 40. Take away 36. 40. Take away 36, right? You'd just go on forever. The other approach, if you wanted to, is to make fractions out of it. So keep your 1/2 and your 1/3 separate. Floff your halves or fifths or whatever until you make tens. So this one you would floff to get a 5 with a 5. So 5 on top and bottom gives you 5/10 times 1/3. And then use commutativity to bring the 5 over and just leave your 1/10 in front, and you're going to multiply by 5/3. Okay, 5/3. Now, if you multiply by 3s, right, because we love 3s, because that gives us a 9. So I'm going to floff this little trucker right here. And then you say, okay, so that's 15. So what I end up with is I have 1/10 times 15/9. Well, 15/9 is 1 whole time and 6/9, because that's just the mixed number form, which is 1/10 times, and then 6/9. We know the beauty of the 9s becomes 1.6 repeating. 1/10 simply moves and everything becomes 1 decimal place smaller. So that is how I could do it with fractions. So a couple approaches you could do there. All right. So again, what I can see from the beginning guides me, but the work I have to do in the middle to get the actual values is different. Okay, so let's see here. What else do we have? If we had something like a 3 to the 7th, 5 to the 4th, I don't know. We'll do a 2 squared, and I'll do times 7. Okay, just because. So what this tells me is, if I group all my 2s and 5s together, kind of in my mind, I'm pretending the 7 doesn't exist for a moment, as long as we're in simplified form. And that would tell me right here, 4 digits. This, if it was terminating, it would terminate in 4 digits. Okay, but it's not terminating, right? Because there's a 7 in there. Oh, you stinking 7. So this says that it repeats. It's the only thing in this piece that is repeating. So therefore it repeats in 6 or less digits. The 4 digits are the ones that are not repeating. So I have 4 digits that don't repeat, and then the rest of it repeats in 6 or less digits. So what I'm going to do is I'm going to open up a Desmos panel here, and we can kind of go through and see. So let me pop this out. I got to do a new share. Sorry about that. Sorry for the drama. There we go. So now I'm over here. And if I type in what we had, which was, oh shoot. I remember the bottom, 5 to the 4th, 2 squared. I'll put that in. So I have on the bottom, I have 5 to the 4th times 2 squared times 7. That was it 3 to the 4th on the top? I really should remember these things. What was it? 3 to the 7th on top. All right. So 3 to the 7th, 5 to the 4th, 2 squared times 7th. Let's jump back over and check this out. So I have 3 to the 7th. Okay. So what did we say? We knew from the 5 and from the 5 to the 4th and the 2 squared, there would be 4 digits that do not repeat. Take a look at our answer. 0.1249. After that, because of the 7, it's going to look like the 7 pieces. I end up with a 7142857, 7142857, right? So if you want to kind of see more of the digits, I could call this A, so you can kind of see, hey, is that actually, oh, I keep hitting enter. I don't want to hit enter. I want to hit caps lock. A equals. So there's A. Okay. So now let's do A times 4 digits. So there we go. So that gives me my 1249. And then I'll take away the 1249. And what you'll see is 4714285714285, right? It keeps going. Okay, it links back to sevenths. So that's how you can kind of tell what these are doing. So the 2s and the 5s always tell you how many digits are not doing something. Either it's how many until it stops entirely, or it's how many until it starts repeating. So that's what the 2s and 5s are telling you. The other digits give you additional information. So there we go. 4 digits not repeating. And in this case, it was 0.1249. On the test, I'm not asking you to write the decimal form. I'm only showing you it now so you can see the connection, perhaps. And then it was 714285 repeating. So that would be that number here. But once again, 4 digits not repeating. And then the rest repeat based on what you see. Okay. All right. So that should take care of that component. Hopefully that was helpful. And let me know if you have other questions. All right, off you go.